Here are some hints to do these homework problems. So this first problem, sometimes it's hard to see what they're asking for when they give you a ratio like this. But remember, this appears to be a goodness of fit test because we have one variable and one set of data. But the possibilities, there's 16 possibilities, right? 9 plus 1 is 10, plus 3 plus 3 is 16. So there's 16 possibilities. So whatever the sample size was 100. So right, so it's 9 out of 16 times 100. That's the expected value for the first cell. 3 out of 16 times 100, 3 out of 16 times 100, and 1 out of 16 times 100. Those would be the expected values. So I'm pretty sure this is a goodness of fit test, and you would use these ratios to determine the expected values. Okay, birth order and college choice. So this is, we're sort of treating that as a seems like a silly test, but we're treating birth order as a variable, and it looks, and clearly the college type of college that you go to is a variable. So you have two variables. Here they want to show you the key to this problem is you should stop and say, oh, the expected cell counts are too small. But what they want you to do is proceed with caution, of course. Proceed and then see what kind of standardized residuals that you get and what happens. What happens if you ignore the expected cell count? What impact does it have on the test? Okay, so that's how you do that problem. The cranberry juice, what we have here is it's kind of like that experiment problem we did in class. We're trying to see if women get this urinary tract infection. Okay, and then we're trying to look at different remedies. So drinking cranberry juice is one. Another one is this lactobacillus, something like that. Drink, and a third would be neither of those. So I guess a placebo. So it looks like you have one variable and multiple groups. Women that get the infection and women that don't. So that's a hint there on that one. Okay, in Montana, we're looking at political party affiliation and whether or not you're male or female. So this might look like two different groups, male or female. But if you think about the intent, what is the intent of the study, or what we would want to do with this data? It could very well mean that we're interested in does it matter? So like if you're a Republican, do you have a different distribution of support amongst male and females than Democrats? So it could be that we're interested in independence, and it's two variables. Sorry, I'm losing my voice. So M&Ms, we've done M&Ms before. So we have some expected percents for them, and then we have some values. Okay, so this is sort of calling out for a certain kind of test that you should be familiar with. Okay, now the New York PD and gender. Here we've got clearly a variable, what rank do you have within the organization, and then we want to know if you're male or female. Now, the type of test may not really matter that much on this one, but what you want to think about is because the mechanics are going to be the same, but you might want to think about what are we trying to find, or what do you want to conclude in the end? Do you want to conclude that they're the same, or do you want to conclude that there is a dependency, like in getting in the likelihood of being in the upper ranks of this organization may depend on whether or not you're male or female. I don't know. So consider a test of independence. Both will probably work in terms of answering the major question. Okay, and then finally, problem 20, parents. We're looking at a variable on how working parents and what kind of situation they have. I think, yeah, both parents. But we have two sets of data, one from 1991 and from 2001. So here it looks pretty clear that we have one variable and two sets of data. So that should imply the kind of test that you need to do. Okay, good luck. Those were just some hints. We're going to go over these in class. Do your best.